So if you have your workbooks with you, okay, please turn to page 60. Okay, and today I thought that we would start with a new chapter lah. Okay, and this chapter is written on the top over there. You can see it's called probability distributions. Now, as an introduction to the chapter, the first thing we need to talk about now is this word lah, random variable. Okay, now we know that variables are things that can change. Okay, and you learn that in science, the sciences lah. There are three types of variables. There's the manipulated variable, there's the responding variable, and then there's the constant variable. If you go up to higher levels, this manipulated and responding sometimes is known as dependent and non-dependent variable. Okay, but it is basically the same thing. But variables are things that can change. That's why dalam bahasa Melayu, variable dia punya nama dalam bahasa Melayu dipanggil sebagai pemboleh ubah. Sebab dia boleh berubah-ubah. Contohnya dalam satu kelas itu, for example, your class lah. Okay, everyone's mass is different. Okay, for example, I'm sure that Sean has a smaller mass than me. I don't dare to say lah. Okay, for example, Sean has a smaller mass than me. So our mass, the mass itself, okay, is a variable. Okay, just like another one, height. Okay, so Sean has a smaller sorry, Sean. Sean has a smaller height than should I say everybody in the class? No lah, kan? There are people that are small. Okay, Sean has a bigger height than Eva, contohnya. Okay, so mass, height, everything that we can put a number to lah, okay, is considered a variable. Okay, but we are very used to this lah, mass, height lah. But in mathematics, certain things that you can count can also be called as variables. For example, inside your class, how many hours do you study a day? Okay, the number of hours, bilangan jam yang kamu belajar setiap hari can also be considered a variable. Okay, for example, let's say if I do a survey in your class, okay, and then saya dapati bahawa, oh, okay, in a class of 你们是35个人 okay, 35 people, right? Okay, your class got 35 people. We find that only 2 people study for 6 hours a day. Okay, and the 2 people are, let's say Garrett and Adam lah. I don't know why. Sorry. So Garrett and Adam, you study for 6 hours a day. Okay, and then let's say another one is 4 people, they study for 5 hours. Okay, and then we find that a majority, 20 people, study for half an hour a day. Okay, for example, okay, just an example. I'm not saying that, but if kalau kamu tergolong dalam kumpulan ini kan bagus kamu terasa sekarang lah. One day you study half an hour, what happens to the rest of the 23.5 hours in a day? Gosh. So all these things are all known as variables. Things that can change from person to person. Okay, things that can change from person to person. Now, why is it called a random variable? Because random variables are variables that you can count. There is a numerical value. Ada nombor pada variable tersebut. There are some variables that cannot be, that got no numerical value. For example, do you think today is going to rain? Do you think today is going to rain or not going to rain? Akan hujan, tidak akan hujan kan? Itu kau tidak boleh kira. But it is a variable. Hujan atau tidak hujan kan? Dia boleh ubah. Some days it can rain, some days it cannot rain. But you cannot count. Okay, so we don't call those random variables. But in mathematics, in maths because we are studying numbers, so we have to call these variables random variables sebab dia ada nombor di sebaliknya. Okay, for example, mass, let's say Sean is 100 kg lah contohnya. Okay, and I'm, let's say, 150 kg. So all these are numerical values. Height, okay, Eva is 100 cm contohnya. Okay, and Sean is like 200 cm. Example lah, okay. Sean wishes lah dia 200 cm. So anyway, all the all these are numbers. Okay, so dia ada nombor yang boleh mewakili the variable. That's why we call it a that's why we call it a random variable. Okay, a random variable. Dia adalah variable yang ada nombor. Okay, how many hours you study a day? Bilangan jam kamu belajar dalam satu hari. The variable is how many hours you study the day. The random is, 6, 5, 4, 2 hours, 1.5 hours. All these are the numerical values. Okay, now there are two types of random variables. Okay, so kita buat pengelasan sudahlah. Two types of random variables. I'm going to call this RV, okay, because I'm very lazy to write random, balik. So the first one is called discrete. Okay, discrete random variables, and the other one is called continuous. Okay, continuous random variables. And this particular chapter talks about both the random variables. How to get the probability of a discrete random variable, the other method, how to get the probability of a continuous random variable. Okay, so there are two types of random variables, discrete random variable and continuous random variable. Okay, so there are two. One is discrete. Okay, and the other one is continuous. Okay, now if you take a look at the notes on your page 60 in your workbook over here, okay, dia cakap the values of discrete random variables are obtained by counting. Kamu boleh kira, okay, and take on whole number only. Whole number means tiada decimal place. Okay, you can write a note on your workbook. Whole number means there's no decimal place. It is 0, 1, 2, 3, 4, 5. Very nice numbers, whole numbers. Okay, so an example of discrete random variables is how many times. Okay, in a week. Okay, example. How many times in a week it will rain? So let's say you do a kajian, you do a research. Okay, then you say, okay, dalam satu bulan ini saya mau tahu berapa kali dia ini. Okay, so these are discrete random variables. How many times in a week it will rain? Okay, another one is how many people will pass at Maths from 5 ST. Okay, the probability of how many people will pass at Maths in 5 ST. Okay, those are definitely you can count lah. It cannot be 23.2 people. Where got such thing? Because orang dia adalah discrete. Okay, now continuous random variables are obtained not by counting but by measuring. Okay, kamu kena ukur. Okay, and then you take on real number values. Now, when we say real number, this includes whole numbers, tetapi dia juga termasuk decimal places. Okay, so for example, examples of this, okay, very common examples are mass. Okay, mass of students. Okay, height of students. Height of people doesn't matter because 170.1 and 170.2 is two different values. Okay, and that's why we have to call them as continuous random variables. Okay, so this is the big picture that I want you to get. The whole topic about probability distributions. Sorry, yeah, it is that time of the day lah. There's somebody outside my house, so my dog is very excited. Okay, so discrete and continuous random variables. This whole topic of probability distribution is to find the probability according to the type of random variable. Okay, there are only two types of random variables at your level. So we are going to learn two methods of finding the probability depending on the situation. Okay, this is the big picture. I want you to get the big picture first before kita masuk ke dalam before we really go into the chapter. Okay, get it into your mind that there are two types of random variables. Discrete is done by counting, and they mesti whole number. There's no point. Okay, continuous yang ada perpuluhan, yang ada decimal, yang ada negative. Okay, and the way we get the data for discrete is by counting, for continuous is by measuring. Okay, so these are all new terms. Memang perkataan yang baru. Okay, but the more you say it, okay, the more it will be easy for you to understand. Discrete random variable, continuous random variable. Okay, so let's take a look at question A. Question A. Okay, so state lah, tell me whether it is a discrete random or a continuous random variable. So in the example given, the number of children in a family obviously is a discrete random variable. There's no such thing as I have 3.4 children. What does 0.4 children mean? Slap your face, okay? The length of leaves on a mango tree. Think about it. Panjang kan mesti kau ukur, bukan kau kira. So kalau kamu kena ukur, is considered a continuous random variable. Okay? Number 1. Height of students in the class of Form 5 are mana? Pandas. Discrete or random? Bodoh, discrete or continuous? Pandas, please.
Apa sah question tadi?
Soalan nombor 1. Height of students bahkan.
Yeah.
Okay, is it a discrete or continuous random variable?
Continuous random variable.
Sebab?
Dia measuring.
Dia kena measure. Okay, you have to measure lah. Okay, very good. So this is called a CRV. Okay, continuous random variable. Good. Number 2, number of fruits. Bilangan buah pada setiap pokok. Number of fruits. Okay, sorry. On a papaya tree. Okay, number of fruits on a papaya tree. Maya, is it discrete or is it continuous?
Yes, sir. Sorry. My mom panggil tadi. Which one? Sorry.
Number 2. Number of fruits. Discrete or random? Bodoh, discrete or continuous? Okay, it's discrete. So DRV. I'm just going to write the shortcut. Okay, number 3. Rosani. Number of cars in a school park. Discrete or continuous?
Discrete.
All right, very good. Discrete. Okay, because you can count the number of cars. Okay, very good. Number 4, time taken by Form 1 students to run 400 meters. Sean, discrete or continuous?
Continuous.
Okay, it's continuous because there is a difference. You have to measure. Sorry, CRV lah. Okay, it is continuous because you have to measure it, and then the different values are different. Okay, it is not countable. Okay, so let's take a look at this. I want to skip question B. You can look at the answers if you want, but I want to go to question C. Okay, this is my main job for today lah. Question C. So question C, the question says determine each of the following probability distributions using a tree diagram. Now you have learned tree diagram in mathematics with Cikgu Kok lah. I hope that you have learned this. Okay, and then we tabulate all the properties in a table. Now you can use the example over there, but we're going to go straight into number 1. Okay, and then we think about the situation. Okay, so number 1, the experiment. Listen very carefully and follow as closely as you can. Number 1, the question is a fair coin. Okay, you have a coin and then you toss it 3 times. Okay, you toss it 3 times. So the random variable x Okay, the random variable. This is definitely a discrete random variable. Okay, X is the number of heads. Number of heads. Okay, let's just recap. When you toss a coin, bila kamu lambung duit shilling, kan, what are the outcomes that you can get? Apakah kemungkinan yang kamu akan dapat? Chanel, when you toss a coin, what happens? Kamu akan dapat apa?
Tails or heads?
Tails or heads, okay? So there's only two outcomes. Like you either get tails or you either get heads. Please don't be so like, oh, okay, ini adalah inception. Okay, so terus the coin jatuh begini. Okay, no such thing. A fair coin either falls heads or tails. So let's say, let's build a tree diagram. Okay, tree diagram. So, first time kamu lambung, okay, you get heads and tails. Either heads or tails. Okay. Second time kamu lambung, let's say first time kamu dapat heads, the second time kamu lambung, you also have a fair chance of getting head or tail. Sama juga dengan di bawah sini. Okay, you know what? I'm going to change color so that you know the difference between the first and the second time. Okay, so first time saya lambung is brown color. Second time saya lambung is, I don't know what color is this. Okay, ini second time saya lambung. Okay. Okay, third time saya lambung, green color. Okay, this. Astaga. I have no more space already. Sorry. H and T. Okay, so what does this tree diagram mean? Tree diagram, I hope that you have done this when you are doing maths with Cikgu Kuop, okay? Because this is not something that I'm supposed to teach you. You're already supposed to know this. Okay, so what does this mean? Let's follow the path. Okay, kita ikut dia punya lintasan. First time kamu lambung, kamu dapat heads. Second time kamu lambung, kau dapat heads. Third time kamu lambung, kamu dapat heads. So this is first time head, second time head, third time head. Okay. The next lintasan is first time head, second time head, but the third time tails. So this is head, tail. Okay. And then you can proceed to do the rest. Okay. So this is head, tail, head, tail, head. Okay. And then this one will be head, tail, tail. Sebab dia H, T, and then T. And then we do the same for the rest. This will be tail, head, tail, head, tail, tail, head, tail, tail. Okay. So, the question is this. Okay. Setiap satu daripada ini kaki ini bahkan, what is the probability? If this is a fair coin, okay, what is the probability of getting a head? Adam, apakah kebarangkalian mendapat kepala dalam melambung duit shilling? Is Adam here? Adam adakah?
Yes, sir.
Ya, apa kebarangkalian mendapat kepala?
1/2.
1/2. Okay, very good. Okay, that means because it is a fair coin. Okay, so 1/2, so sini mesti 1/2. Because in each set, okay, dalam setiap satu kejadian, jumlah kebarangkaliannya mesti 1. The total probability must be 1. So likewise, all the way, all this is also 1/2, 1/2, 1/2. Because it is the same coin lah. Kita bukan menggunakan duit shilling yang berlainan. Okay? So, now let's consider this. What is the probability of head and head and head? 3 kali head. So the probability, okay, I'm going to write the probability here. 1/2 times 1/2 times 1/2, which will give me 1/8. And sebab kepala. So 1/2 times 1/2 times 1/2 equals to 1/8. Okay, I'm doing this very slowly, although actually kamu sudah belajar ini ya dalam matematik, the other maths, okay, just to make sure that you refresh this lah. And we find that actually for all this, even HHT pun sama, kepala 1/2, kepala 1/2, ekor pun 1/2, you will get 1/8. Okay, so 1/8, everything lah is 1/8. Okay, 1/8, 1/8, 1/8. Okay, all these are over there. Now, we come back to the variable that we want. Okay, the variable that we want is the number of heads. Okay, in this first situation, how many heads are there? Astaga. In this first situation, there are 3 heads. In this second situation, there are 2 heads. Okay, 1 head, 1 head, 2 heads, 1 head, 1 head, 3 heads. Okay, bilangan kepala dalam set kejadian tersebut, di sini ada 3 kepala. Sini adalah 2 kepala. Kenapa saya pilih kepala? Sebab soalan yang minta kepala. Okay, the question say how many heads do you get after you try 3 times? What is this one? Okay, so let's look at this. Sorry lah, the last one is not 3. The last one is 0. My bad. Sorry, the last one is 0. Okay, yeah, did somebody correct me for this? Okay, so so when we look at that, okay, when we look at this situation, there are 4 different types of outcomes. Okay, you will get x equals to 0 in this case. Okay, x is the number of heads. In this case, you get 0 heads. Okay, another one is x equals to 1. This is x equals to 1, x equals to 1, x equals to 1, x equals to 1, 1 head. Okay, another one is x equals to 2, which is this and this. You get 2 heads. Manakala x equals to 3 is this last one. Okay, so there are 4 different situations altogether. The number of heads that you can get is a discrete random variable. Dan ada 4 kejadian yang mungkin berlaku. Kamu mendapat 0 kepala, kamu mendapat 1 kepala, kamu mendapat 2 kepala, kamu mendapat 3 kepala. Okay, and so let's take a look at this now. What is the total probability, okay, of getting 0 heads? There's only one situation where there's 0 heads. Kan? So we find that when x is 0, the probability is 1/8. Seperti yang kita sudah kira. Because there's only one situation. Okay, I'm going to build a table now. Sorry. Okay. 1, 2, 3. So when x equals to 1, how many probabilities are there that have 1 head? 1/8, 1/8, 1/8, 1/8. Sorry lah, something is wrong with me, right? Saya salah kira lagi balik. This is 2 heads lah kan? HH. Astaga. Sorry. Okay, so this one, okay, this one is HTH, 2 heads. So only these 3. So 1/8 plus 1/8 plus 1/8 will give you 3/8. And then the same thing we do for when x equals to 2. Count, total up the probabilities of 2 heads. 1/8 plus 1/8 plus 1/8. Also 3/8. And then the probability of 3 heads is only 1/8. So 1/8. Now, how do you know whether your table is complete? Now, your table is complete, okay, if the total probabilities, okay, the total probabilities of a discrete random variable must be equal to 1. Cuba kau kira ni, 1/8 tambah 3/8 tambah 3/8 tambah 1/8. If the answer is 1, then your table is complete. Okay, then your table is complete. Okay, and you will obviously find that that's what's happening lah. Okay? All right. Sorry, I need to carry on to this. What I want you now to do is turn to page 63. We're going to use this table. Okay, so I'm going to rewrite this again. X and P, 0, 1, 2, 3. The probability is 1 over 8, 3 over 8, 3 over 8, and 1 over 8. Okay, so what we can do now with this one is we can draw a probability distribution graph. Okay, and this is my main purpose for today. I want you to learn how to draw the probability distribution graph. Now, the good news is this graph is super easy. Okay, all you have to know is, number one, obviously it is a graph like this lah. Okay, now since there are only 4 values here, 0, 1, 2, 3, kita jangan 0 di sini. Okay, probability distribution graph dia lain sikit lah. Kamu ambil saja 0 and then put it here. 0, 1, 2, 3. So it's a little bit different than normal graph. Okay, this is a special kind of graph which is called a probability distribution graph. Okay, now then the next thing you do is you just take these values. There are only 2 values. It's either 1 over 8 or it's 3 over 8. There's no other values over there. Okay, so what you can do is you put 1 over 8 over here and you put 3 over 8 up here. Okay, I know that in your workbook, dia siap lagi dia bagi garis-garis bahkan. Okay, kamu pandai-pandai lah, you just pandai-pandai to adjust. Now, this is the best part. Okay, this is the easiest graph that you will draw in this entire world. 0 is 1 over 8, right? Okay, so we plot first lah. Okay, 1 is 3 over 8. 2 is 3 over 8. And 3 is 1 over 8. Okay, so once you plot already, then we draw the line. Okay, why am I using the same color? Okay, we draw the line. Take a look at the line. The line is like this only. Dun, 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 dun. Sorry, it's supposed to connect to the X lah. Okay, fine. It's supposed to connect to the X. But that's it. This is the probability distribution graph. Okay, so it's like whoa, okay, line lagi daripada graph. It is not a histogram, it is not a cumulative frequency, it is not an OGIF. Okay, it is a probability distribution graph for discrete random variables. Okay, I repeat, this is a probability distribution graph for discrete random variables. Okay, this is the easy part, drawing the graph. Okay, kalau kamu betul-betul mau, you can do this lah. Px equals to R, and then after that, this will be R. Yeah, okay. I will explain what is this R in a little, in the next class lah. Okay, for now, kamu anu saja. Okay, this is the probability when the random variable equals to 0, equals to 1, equals to 2, R. Okay, so different kinds of R will give you this. Okay, this is the easy part. The difficult part is figuring out the tree diagram. Ini yang ada mencabar sikit. But if you remember what you were taught when you were doing probability with your maths teacher, this should be quite okay lah. Okay, but to help you, what I want you to do, what we're going to do is I'm going to do number 2 and number 3 in page 62 again. Okay, but because dalam kamu punya workbook bahkan C and D, okay, C and D actually they are connected. So soalan C1 kan, dia cakap plot the graph for each of the probability distributions in part C. So di sini kau lukis balik this yang kau nampak di screen sekarang lah. Okay, so number 2 nanti you draw here, number 3 nanti you draw down here. Okay, this is number 3 and you draw the graph down here. This is my main work for today. Yeah, this is my main work for today. Okay, let's take a look at number 2. I'm going to help you to draw the tree diagram, but I want you to figure out this one on your own lah. Okay, so the question is, 2 balls are drawn randomly, one by one without replacement, from a box containing ada 3 black, okay, and 2 white. So how many balls are there altogether? There are 5 balls lah. Okay, so the random variable X is the number of black balls yang kita mau. Okay? Question must always give you the random variable. The random variable is the number of black balls. Okay. So dia punya soalan adalah kamu ambil satu, lepas itu kamu tidak letak balik. Dia cakap 2 balls are drawn randomly, one by one, without replacement. Listen carefully without replacement means dia tidak letak balik. So the first time kamu ambil bola ada berapa? Ada 5 balls. Then you put that ball aside. The second time kamu ambil bola, ada berapa sudah bola dalam kotak itu? Tinggal 4. So the probability is a little bit different. Okay? Now, let's try to build the tree diagram. Okay. The tree diagram will look like follows. The first time, hanya ada 2 kemungkinan sajalah. You either draw a black or you draw a white. Okay? Second time, the same thing. You either draw a black or white, or you draw a black or white. Okay? And then dia cakap 2 balls saja. Okay, so this is a little bit easier than the one just now. Sebab dia, yang ini dia lambung 3 kali bahkan. Kalau dia lambung 3 kali, kamu punya lapisan tree diagram ada 3 lapis. Tapi oleh sebab in this question now, you only take 2 balls out. So this is the first lapis, first ball. This is the second lapis, which is the second ball. Okay, now, what is the probability of getting a black ball the first time? Okay, the probability of getting a black ball, the black ball the first time. Garrett, can you tell me? What is the probability of getting a black ball the first time? This one.
Um, 3/5.
3/5, very good. Okay, and because of that, the white ball will be 2/5. Sebab tinggal, you know. Okay, now, this is where you need to be careful, the second lapis, because the second lapis, dia tiada replacement. Okay, so the first time you take out of this one is a black ball. Let's consider this. What is the probability of getting the black ball the second time? If this is very confusing for you, take out 3 black ball and take out 3 white ball and play out the situation in your mind. You have taken out the black ball and you cannot put it back. What is the probability of getting the black ball the second time? Abigail?
Can you repeat that, sir?
Okay, so the first, I'm going along this path now. I'm taking out 2 black balls now. So Garrett just now said, the first time I take out a black ball, the probability is 3/5 because there are 3 black balls and there are 5 balls altogether. Now I've taken that black ball out and I put it aside. And then the second time I want to draw out another black ball. So Abigail, what is the probability of drawing out the black ball the second time now?
Is it 2/5?
2 is correct, but it won't be over 5 because remember, we don't put the original black ball back in the box. So how many balls are there now in the box? If I've taken out 1.
2/4.
Very good. Okay, 2/4. Okay. Okay, very good. Then the next, okay, let's consider the next lintasan. Changing color, next lintasan is black and then white. So the first one, black, okay lah, done lah, 3/5. Okay, what is the probability of getting a white ball now? Eldon, on the second time.
The white ball, sir.
Yeah, the white ball, this green color that you're seeing now.
2/5.
2/5 meh?
Yeah.
Second round. I have already taken out this lintasan. Saya ambil dulu bola warna hitam.
1/2.
Yalah, 2/4 lah, or 1/2 lah also can. Because there are 2 white balls and then there are 4 balls in this one. So take a look at this. In a situation where there is a non-replacement, okay, dalam situasi yang melibatkan kau tidak letak balik, you take out one and then you throw away, the number on the bottom must always reduce by 1 on the second lapis. First lapis 5, second lapis 4, kalau ada lapisan ketiga kan, dia akan jadi over 3. Sebab kau tidak letak balik. Okay, you always put it aside. You always put it out. So there's always going to be less one ball the second time you're taking it. Okay, let's do another lintasan. First, we are taking the white ball and then we are taking the black ball. So Garrett has just now said that the white ball is 2 over 5. So the first time I take a white ball, the probability is 2 over 5. What is the probability of getting a black ball the second time? Celeste?
Two over 4.
Black ball or? Think about it. The first time when I draw out, I got a white ball. And then I put the white ball away. The second time when I draw out, I get a black ball. So far, your over 4 is correct. But think about it. How many black balls are there if I've taken out the white ball at first?
3 over 4.
Okay, very good. 3 over 4. Okay, a message is coming in. Okay, now let's consider the last one. Okay, which is I've run out of colors. Okay, yellow color. First time white, second time white. So the first time white is 2 over 5. Okay, the second time white. Kali kedua kamu dapat warna putih. Fadila? What is the probability of? Okay, very good. 1 over 4. Now let's combine all the probabilities together. Okay, so in the black situation, it is 3 over 5 multiplied by 2 over 4. 3 over 5 times 2 over 4. Okay, the second situation is black and then white, which is 3 over 5 times 2 over 4. This one lah. Okay, in the third situation is white and black. White is 2 over 5 times 3 over 4. And the last situation is white. Okay, white is 2 over 5 times 1 over 4. Now I'm going to, sorry, can somebody please calculate this for me? I'm very lazy to calculate now. So can somebody calculate this for me? Give me the black how much, black white how much, white black how much, white how much?
Black 310.
Okay.
Black white 310.
Okay.
White black 310.
So boring, right? Sorry,
White
the last
white 110.
Okay, 1 over 10. Okay. So now let's consider the random variable that we want. The random variable that we want is the number of black balls. So in this case, x equals to 2. The number of black balls that we want. In this case, the number is 1. This one is 1. And this one is 0 black balls. Okay. So when we transfer this into a table, okay, let's transfer this into the table. Okay. So we have x. There's only 3 numbers lah, 0, 1, and 2. Kan? Tengok 0, 1, and 2 saja. So what is the probability? When x equals to 0, it's only 1 over 10. When x equals to 1, there are 2 cases where x equals to 1. So what do we do with these 2 probabilities? We add them together. Okay, we get 6 over 10 or 3 over 5. Sama aja lah. Okay, doesn't matter. And then lastly, x equals to 2 is 3 over 10. Okay, now that we have our table, we transfer it into the graph. So the graph is in page 63 at the bottom over here lah. Okay, so as I said, the graph is the easiest thing in the world to draw. Okay, first of all, you do this. You put the 0 as the first one, 1 and 2. Okay, no such thing as origin. Okay, tiada kaitan dengan asalan ni. Okay, this is a probability distribution graph. So different rules apply. Here is R, here is P, X equals to I. Okay, because dia punya nombor di bawah adalah berlainan, please be careful lah. Okay, make sure that dia masih tersusun mengikut dia punya size. Okay, so here is 1 over 10, here is 3 over 10, and here is 3 over 5. Okay, please double check to make sure. Don't just say, oh, 1 over 10, 3 over 5, 3 over 10. Okay lah, susun saja. No, no such thing. Okay, you need, ini masih perlu disusun mengikut size nombor. Okay, alright, so 0 is 1 over 10, 1 is 3 over 5, and 2 is 3 over 10. And the last step to draw the graph is just a straight line from down all the way to here. Macam begini. Okay, and when you have done this, always double check to make sure that your total probabilities mesti sama dengan 1. Okay, so 1 over 10 plus 3 over 5 plus 3 over 10, and you get the answer equals to 1. I don't even know whether there's any point showing you this. Oh, sorry. Okay, if you can see the calculator lah. Once you know that the total probabilities in the box is 1, then you know your graph is complete. Okay, then you know your graph is, means all your steps, you have already done it correctly. Okay, so these are two examples. Okay, these are two examples of how to do from the tree diagram all the way to the probability distribution graph. When you were doing maths with your maths teacher, you probably would have stopped up to here lah. Okay, this part ini semua ini sepatutnya kamu sudah buat. My part, okay, the one with the add maths, which relates to tomorrow's class, is this one. Okay, doing the probability distribution graph. And why is it so important that we need to know how the probability distribution graph? Okay, I will tell you this tomorrow. Come for no, sorry, when is our next class? Oh, I will tell you this on Wednesday. Come for Wednesday's class. Okay, and then I will let you know.